This conference will now be recorded.
Is my OneNote visible to online students?
Yeah, it is visible.
Uh, Please mute yourself, everyone. So here, while giving the physical design demo over here, I will walk you through I will walk you through how the course structure is, how we are going to move ahead with advanced topics, right? So before moving ahead with advanced topics, we will be covering certain basics also, right? So I will move you through all those things. Uh, Let me give you the list of what all things we are going to discuss here. So we will be discussing about course structure and topics covered. Then how, while you are in the course, what all things you need to pay attention to get the placement support. Right towards the end, we give the placement support also, and that is till you are not getting into industry, you can be the part of the placement support. But how it works, that I'm going to explain. So placement support. um, Interview prep. Then next, I'm going to I'm going to give you a gist about that. What is the difference between? So there are in VLSI there are a lot of things you must be hearing: front end, back end. In front end, there are different job opportunities. In back end, there is synthesis, STA. Front end, I don't know much about, but yes, I'm a back end guy, so I know about it. So back end, we have synthesis, STA, we have PNR, right? We have clock team, we have power team, all those things. So how they are segregated, classified, and how they create different job opportunities for you, right? So that I'm going to explain here, so that you will get the idea that by first knowing what is mean by chip designing and chip fabrication. If you get this idea, then it will be clear that if you are working on physical design, at which part of this process you are working on. Fine. Then I'm going to discuss about a sick design flow. Some like I'll give you the introduction of advanced physical design topics. That what we actually do in advanced physical design, right? And then final sign off and takeout process. Right. So all these things we are going to uh, discuss. So at any point of time, if you are having any question, you can just let me know. Okay. So now first let me tell you that how the course structure is, right? So what all topic we will be covering here, right? So your this training is divided into two phases, right? So roughly the training is of 6 months, right? The 2 months are dedicated to all the basics, right? So in basics, we are going to cover digital. See, as you are a VLSI engineer, it's a core subject, right? So without knowing digital properly, without, even though we are having 7-8 years experience, 2-3 years of experience, still sometimes the basics are asked. What is the ID question? What is CMOS? What is latch up issue? Right? Draw this, draw that in like uh, yeah, like simplify using the K map. So all those things still is asked. And as a fresher, it is 100% asked, because nowadays a lot of students are getting trained, right? So their first like how they are refining, how they are selecting the students, the first are the written test, and mostly the written test are based on the basics, right? So you have to be really very well versed with digital concepts. So here obviously we are engineers, we know about everything, flip flops, like all the combinational sequential cells, how do they work. We have been learning it from throughout our engineering, right? But still we need a little bit of brush up, so that we do over here, right? So those two phases, and then so that is digital, and then concept of CMOS, right? So ultimately the IC chip which you see, so it is actually fabricated using FinFET. FinFET is nothing but, first you need to know how CMOS works, and then one fin is added, that is FinFET. Correct. So we teach CMOS also, and like basics of CMOS, right? CMOS is really deep subject. If so any one of us from here have done post graduation, they must be knowing that in post graduation we are having full one a semester subject of CMOS. It's really deep. So here we cover CMOS as an intuitive perspective, right? We do not do the long numerical calculations and all, but we understand the logic, how it works. Intuitive perspective, we can say, right? So CMOS is covered, digital is covered, and now VLSI, here we work on Linux, Unix, Linux, right? So the operating system, as far as VLSI engineer is concerned, we do not work on Windows. Our tools are really heavy, right? And mostly the licenses which are there, it's kept in some other server, right? So that server access we can just have by using Linux, right? So that is Linux system, because it has the ability to work 24/7 for 365 days, right? So that's why we are using Linux, and 90% of us do not know how to work with Linux, right? Because it's totally different operating system. We have habit of using Windows, right? So we teach, some days are dedicated on learning Linux also, right? So it is totally command based, right? Okay, you can click also, you can do all those things, but uh, as a physical design engineer, you have to avoid using mouse. When we are working on tool, you should know what are the commands doing, like creating a library means creating a folder, deleting a folder, opening the remote folder which is there somewhere else, copying some files in our so everything you should do without touching the mouse. For that you should be knowing commands, right? So Linux training is dedicated to that, how the Linux works and how the command works, right? So that is dedicated. And then so let me write all those things. So we will be so here phase one, it will be PD basics. Phase one will be PD basics. The topic covered will be first digital basics, then CMOS basics, right? Then Unix or Linux commands. Then so these will be covered. I've given you the idea also that why are we covering these things. Then fourth, Yes. So the next thing we are going to give you the idea about is TCL language, right? So what happens? So basically, in industries, the flow is ready, the command. So it is command based. The tool which we are using, having all of the commands. So if I am having in my file, if I am having all the commands, I can just source it. I can do full PNL, right? So the flows are ready, but nowadays the more focus is on automatizing the all the process. For example, you are facing certain issues, certain violations, certain errors are there. You want to clean it, right? And errors are in thousands, right? Manually, you cannot do it because it will be a waste of time. It will require you 2 to 3 days if you manually keep on fixing those issues, right? So we try to automatically do it by doing certain tickle scripting, TCL scripting, so that you can just source the script and that work will be done in within some seconds, right? So tickle scripting is really important nowadays, right? Tickle, CMOS, so the tickle being most important as a physical design engineer. So we are going to do tickle basics, right? It is nothing but tool command language. Tickle is nothing but tool command language. Then tickle basics we are going to cover. If you want, you can I close the I'll close the windows. Just give me a minute, I'll close the window. Sorry for the disturbance. So now we will be covering tickle basics also, right? So after that, so just Linux is done, CMOS is done. So next is when tickle is done. After that, we'll give you the gist of. So after that, actually, we will move ahead with the advanced topics, right? Advanced means lab plus theory, right? So basically, so just to give you the idea that what we are going to do in physical design, you should have some basic idea that what is it really. So we take physical design basics. Digital before I missed one thing. Before physical design basics, along with Linux, we also do GVim commands. Along with Linux, we also do GVim commands. So Linux is an operating system, right? And GVim is so there is a file tickle scripting. So many how to close it, how to open it, how to find. So in VLSI there are the files, input files, output files which you write. They are having the lines in lakhs, 5 lakhs, 6 lakh, basic input files having 3,000 lines, 6,000 lines, right? If you want to search something, or if you want to delete certain things which are present in multiple places, right? So manually doing this searching and everything will be time consuming. So you have lot of shortcuts for it, right, to handle these like bigger files, right? So those are called as GVim commands, right? you should be really well versed with the many of the GBIM command, right? How to search rather than going, clicking, searching, typing. It is really time consuming. If you see any experienced person working on tool, he will never touch the mouse, right? He will just use all the commands, everything, correct? Even closing, opening the file doesn't require to click on that cross which we are having here and all those things, correct? So here we give all those information, GBIM command along with the links, right? And towards the end, we give you the idea that what we are going to do in physical design. So this is actually so out of 6 months, 2 months is dedicated to all these things, right? CMOS goes on for 10 days. Digital basics goes on for like 20 days or something. Mostly digital basics will take time. You know, digital is a vast subject, so it takes time. GVIM Linux will take 10 to like 15 to 20 days. Tickle will take again approximately 15 to 20 days, like that. So depending on class. So it is, and here we do not concentrate on that this is our timetable. If, for example, I'm teaching you Tickle, right? So the management has told me I have to finish it in 15 days, right? So even though you're not understanding, I have to finish it in 15 days, I will just go through it faster. We never do it, right? So here we are okay with if little bit delay in training is happening, but we make sure that the slowest student in the class is also understanding and going along with this. So we do not go by the timetable. We have roughly estimated these days, but you can say plus minus some days you have to. So if you are faster, you have to bear with it, and if you are slower, don't worry, we will be with you, like that. So that's the phase one of all the basics, right? Then if you have any questions till here, you can ask me. Online students, you can unmute and ask me if there is any question meanwhile. My screen visible? I have got one message. Screen is not visible. I hope my screen is visible to everyone.
Yeah, ma'am.
Yes, ma'am.
Okay. Okay. Starts phase two. So here it is PD advance. So here, now PD advance is basically PD advance is basically divided into theory and practical, theory and lab, right? So theory here, first theory basically happens in, so here physical design course, Friday is your day off, is your week off, right? Fridays you don't have any classes, it's week off for you. Saturday, so theory, Saturday and Sunday. We have theory classes on Saturday and Sundays, right? So theory classes basically is covered by the industry professionals. So they are already working in industry. So weekdays they cannot come here, and so they come or online, whatever is their availability. Mostly they will come online. Online will be there or offline will be there. Mostly they will come also here. So the industry, they teach the theory part, right? So that happens. So the classes will be off. So all the classes actually will be off. Classes duration will be of 3 hours. Right? All the classes, whether it is basics or it is advanced. Today also I'm going to take 3 hours. Right? So we take it for 3 hours. After 1.5 hours, we take 10 minutes or 15 minutes of break, and then we continue. So it goes on for basics as well as labs as well as your theory. Right? So the classes duration will be 3 hours, and the timings actually throughout the day we have two slots where the classes can go on. So I am talking about timings on weekdays. So timings on weekdays, we have two slots. One starts with 9:15 a.m. to the class ends at 12:15 p.m. This is one slot. Another slot is in the second half, which start at 1:30 p.m. to 4:30 p.m. Right? So depending on, so if you are joining the classes, depending on, so these classes, I cannot tell that what is the like basics will happen sure for sure at 9:15, and this is not the case, right? You can get any of this depending on availability of the instructor, right? Because many schedules are going on. So, but you will get out of this. So these are the timings on weekdays, and we are timings on weekend. Mostly weekend classes starts at 10 a.m., 10 to 1, right? Or sometimes the second half also, if the trainer who's coming, who's having two sessions, you'll get the second half also, right? But mostly it's 10 to 1. And weekend, so this is timings on weekdays. So weekdays, we are only going to have labs, right? So this is for weekday students. So many students they come for weekdays classes. So for weekday students, we are going to have labs on weekdays, and from that will be from Monday to Thursday, and the timing reduces. So this will be timing for weekday labs, correct? So timing for weekdays, Monday to Thursday, and lab. Friday you will be having off, and then timing for weekend. So this is theory, 10 a.m. to 1 p.m. And then second half also sometimes, but this is mostly the case, right? So that will be your timing. And some students who are, so they are working professional, already doing job or something, want to change. So they just opt for weekend classes, right? So the theory lectures for weekend as well as weekday students, they will be common. So, for example, you are a batch three students, right? B3 students. So, weekend as well as weekday students, the theory lectures which are going to held on weekends, Saturday and Sunday, right? Saturday and Sunday, it will be common, right? And the weekend students are also having weekend labs. So after the theory is completed, the weekend students will be having lab also. Maybe after 1 and 2 hours of break, they will be having lab for another 3 hours, right? So all the classes, whether it is lab or is theory, it's going to go on for 3 hours. Correct? Any questions? Any confusion in lab? In the how the course structure, the timing, and this? So you can ask me. So I can again tell you, I will again repeat. There are two formats. One is weekday, another is weekend, right? The theory, so it is segregated into two, theory and lab. So theory happens on Saturdays and Sundays, taken by industry professionals, and theory is common for weekend and weekday, both the batches, right? And those who have opted for weekday batches, their lab is from Monday to Thursday, right? And any of the time slots, it will be there, right? And for weekend batch, after theory classes, you will be having lab classes also. All the classes are of 3 hours, plus minus half an hour. Okay. So this is how our timings are. So here in advance, so theory happens on Saturday and Sunday. And so I have given this idea extra. So I wrote it over here. Okay. So now we are having, so what all things we cover? So obviously theory, everything, all the fundamentals, you get the idea on theory, right? Everything will be covered in detail. Okay. And those things you will be implementing in lab. Okay. So in lab, we are using synopsis tools, right? So we are using design compiler. Design compiler for synthesis. We are using ICC2 for PN, right? And we are using prime time for timing cell, STM, right? And with prime time, we are also using star RC for RC extraction. We'll get to know along the course what is star RC, right? So these are the tools that we are working on, right? And we also have cadence tools also. So basically it goes right now how the cadence is. So after you are done with synopsis, you can continue with the cadence also, right? So obviously the fee structure and everything is a little bit different. You will get to know the idea about all those things through manager, right? So he will be helping you in all those things. But yes, my work is to just tell you. So after synopsis, we have cadence batches also. So once you complete everything in synopsis, we start with cadence. So in cadence, we are using genus for synthesis. We are using Innovus for placement and routing, and we are using Innovus. Yes. And we are using Tempus for timing sign off. Right. So these are the tools that we are using in cadence. Right. So and yeah, so synopsis here, it's a like the ORCA of the project is ORCA top. We are using there is a around 52 K cells, 52 K cells, 40 macros, right? So this is our, and then we do full PNR on that big netlist, right? Here also in Cadence, we are using a netlist having 64 K cells and 42 macros, right? So that is how we are using Cadence, right? So these are the things that we are going to teach in advanced lab as well as your theory, right? So I hope the ideas are clear. For if you are having any questions, you can let me know.
Yes, hi. May I know your good name?
Hello,
Yeah, may I know your good name?
Ayushi.
Yeah, hi, Aishi. So this 32, this one not cut
Raj,
off and
your voice is little bit. It's not clear actually. It's loud but not clear. Can you?
yeah, okay, give me one. So you said we have you implemented a cut off. Synopsis is not cut off, right? That is mistake, no?
Um,
Hello?
yes, we are using Orca Top. What's your question?
Yeah, technology, which technology we are using?
I'm sorry, I'm not able to actually. Your voice is not clear. I could just
Technology.
understand. Can you type your
Yeah, sure.
Can you type your question? Yeah, please type your question. So, yes, Prithviraj, we do have Fusion Compiler also. So if you want to get hands on it, you can ask for that to our admin team. You need to ask permission, and maybe Fusion Compiler has another course is there for Fusion Compiler. But we do have Fusion Compiler also with us. So you have to get in touch with the manager to get the idea about Fusion Compiler, how the course is. So, but we have the access for Fusion Compiler for sure. Yeah. So Ashok, the experience you will get from this course is you will be able to first you will get all your fundamentals cleared, right, through the extensive theoretical lectures, right? So that is what, and then in the lab you will be able to start working with RTL converted into netlist, synthesize it, and then you will be able to run full PNR. And here we do not uh, give you directly the scripts. I have heard that in many places scripts are given, you just source it, you make some changes, you just source it, and your floor plan, your placement, everything will be done. So we are not doing it here. So if you see if you see any of physical design trainers script, right? We are doing one thing in a multiple ways. We are telling you multiple methods, and we are writing each and everything on a script, right? So that you are, and each and every command we are telling you to go through the man page, do study extensively, apply it here, type it, and all those things. So we are not giving. So here you will get proper idea of commands. If you ask me how much experience, you will be able to do full synthesis and PNR. You will get your fundamentals really clear. You will be able to fix the timing issues in STA. Your STA fundamentals will be cleared, and yes, so you will be able to do full PNR. I can just ensure you that thing, right? You will be, if you are working more tickle scripting, so we are creating more, like lot of 4 to 5 tickle scripts throughout the project we are creating. So it will give you the idea how the tickle scripts will help you automate the process, right? So many students are there who are still working on tickle properly, doing more work on it, right? So we help them in that also. So yes, you will get the whole soul idea from synthesis, like you can say RTL till GDS2. Raj, we are using, so here we are having files of 28 nanometer technology node.
Okay.
Um,
14 also you
uh,
mentioned, right?
28, sorry,
14 also you mentioned, right?
14 files we do have. So after 28 is done, you can do it as an assignment. 14 nanometer files we do have. Hyderabad and Bangalore. See, this is mostly yes. I will say yes. But the clear idea will be given to you by the manager. If you have more issues, I will add him to the meeting towards the end, and you can ask him all those questions. In PNR, are you going to explain in detail about what happens in each stage or just the command to run? What happens in each stage will be extensively explained to you, and we are going to make you run like single command and analyze things. So yes, it will never be okay, take this, copy this file, source this file, your placement is done. It will never be like that. So if I'm giving you any command, I'm going to make sure that you read about it, you understand about it.
Now my audible is clear, no?
Sorry,
Can you hear me like properly? My audible is
I can hear.
clear. Yeah. So that's 64. You said Genus has or Innovus has some memories,
Yeah.
right? 40 something. How much it has? May I know the project name?
Another project. Uh, Seriously. So you are asking that what about another project, right?
Yeah, yeah.
What
That
about the
is
online
implemented on
course? You will
14
not
nanometer
know
technology node or that
the
28 technology.
another project. See, netlist we are having. So whether you use 14 nm file or you use 28 nm file, you will be able to run the whole flow. That totally actually depends on which files you are having. Netlist we can use throughout in Cadence also. And this netlist is the thing which can be used commonly. Library files is what is matters. Like we have library files for 14 as well as 28.
We
What about the
can.
online course? You'll not know the pace of students, right? See, so we are coming here, online, offline, both students are here, right? Like right now, offline students are also sitting over here and online are also there, right? So we keep on, and we know that because online students are looking at the class on the same screen, they have to work on it also. So we really go slow according to them. We keep on asking uh, if you want me to wait, let me, like, tell me that I should wait. So, and there will be especially for online students, we write each and everything. right? So that they can get the idea of, so that they can, even though they are missing onto something, they are having that written thing, right? And yes, we do make sure that online students also are going along. So if you are interactive, if I'm talking, if I'm asking you whether online students are you following, so if you are not following, you are not able to like follow right now, you can tell me and I will be, um, I will stop, I will wait for some time for you to just come to our level, right? And second thing is we do have, so if you join the classes, so you will be getting in skill access. So these, like here, this is also the record. I'm doing the recordings, right? So for your classes, whatever is going on, it will be uploaded to your in-skill portal. So even if you are missing some of the classes or you're not able to catch up with at some point of the class, you can just go to it. You can watch the video. You can do it like that. So that is also one of the support we are having, right? And any which ways, you can next day you can also ask your trainer that this you didn't understand or help us like that. So this is the self-paced. uh
One doubt I have. These classes is going on, right? Generally, with this PD classes and with this basic some one after
Raj,
one
I will,
experiment.
Raj, just if you are using headphones, no, and if you're keeping your mic really close, please do not do it. I'm seriously not able to understand that. I'm just guessing that what you are saying,
Now it is okay. Hello.
or else you can rejoin the meeting. It will be, maybe it will be better.
Okay, sure.
uh So Rajashri, yes, there will be doubt clearing sessions. Not sessions. See, during the class, if you're a part of the regular classes, obviously we are meeting, maybe online or offline. We are meeting every day for 3 hours, right? So lab for physical design, to be true, doesn't go for 3 hours. If you see my lab meetings, right? So 3 hours is the regular class. Then students, if they are online, I keep the meeting on and I fix their issues, whatever issues they are having. So another half an hour, 45 minutes goes like that. So it is not like only 3 hours are there, I will just abruptly close the meeting. No, if you are joining online, we are every day we are meeting. You can ask the doubts in online, right? If you are taking any, if you are doing, if you have missed any class or doing it through e-learning, or you are doing it through this, like watching the videos, what you can say, you can, so there will be, once you enroll over here, there will be one individual group that will be created. In that individual group, all of us will be there, one instructor will be there, not necessarily me, maybe me also, some other PD instructor also, all the admin team will be there, manager will be there, right? So you have to post your queries in that group, that I'm stuck here or I want a support session. So they will provide you, so they will follow, so you have to follow certain method, right? If you want to get a support session, one form they will give you, and or they will just tag me, that because they know what is my schedule. If I'm free, they will tag me, we will connect on video call, and I will like any of the PD instructor which who are there, they will solve your issues, right? So if there is any doubt, if there is any support you want, or technical support, server is not working, you're not able to connect, you're not getting any file or something like that, you have to post it over there. All the people, whether it is finance or it is server related issue, or it is like training related issue, means you're not able to get some files or copy some file, so trainer will be there to look after it. And if some more bigger issue is there, you want something else, so manager will also be there in that group, right? So all the concerned persons will be there. So if you want anything, you just have to post it in that group. So that
No,
is
no, can
how
you hear me? I see.
yes, yes, tell me.
Yeah, it's okay. Then. So generally,
Yes.
like these sessions you said, right? Lab and the theory, some PT discussions. These are go parallelly or like one after one it will go. That means, for suppose today you discuss some basics of digital electronics and basic electronics. This weekend they will start the theory sessions of this course like a physical design synthesis.
Wait, wait, just give me a minute. Um, yes, Raj, can you please repeat your question?
Yeah, what's my question? So you have mentioned in phase one there is some basic concepts is there, right? That is
Mhm.
digital electronics, basic electronics, and some 3D courses, basic courses. These are you said, right? So generally, for suppose today we are taking. So today you are discussing some basic electronics and digital electronics. You are providing some assignments and all, right? So
Mhm.
this week you said right theory classes and some lab sessions. Those are
Mhm.
go parallelly, like weekly, or else
Mhm.
once digital electronics, basic electronics is completed, then after you only start the tool.
Yeah, so okay, so it is like uh when so the question is that does the basic and the advanced course goes parallelly? The answer is no, right? The thing is, first we start with basics. So one day you will be having one 3 hour class only. Only the like weekend students who have just opted for weekend, they will be having on Saturday, Sunday two classes, one theory, one lab, right? But normally it's you will be having only 3 hour class in a day, right? So first, what is how the method is followed over here? That just give me a minute. So like first year basics are completed, right? After that, we take mock interviews, right? And the like out of 10, we give you the marks. Okay, so the mock interview after basic course is completed, the mock interview will be based on all these topics which are done: digital, CMOS, GWIM, Linux, everything, correct? And we give you the marks out of 10, and there is one some threshold, maybe 7 or 8, that threshold. If you get marks more than 8 and more than that, then only you will get to go to advanced course. If you are not getting that much marks, you have to retake that mock interview, right? You have to prepare again and retake the mock interview, like that. So that means we make you first prepared for basics, then only you go for advanced. That is a good thing.
Yeah, okay, thank you.
So now next is, so let me, so these are the things. Now let me first tell you, like I was telling you that this is a topic that I have covered. And after that, so here as so placement support and interview prep, so it is like uh so after the course is complete, so I have told you about one mock interview that we are going to conduct after the basics. After the advance is also completed, we again take a mock interview. So the full so we again take a mock interview, and throughout the process, obviously when we are teaching, we tell you that what are the possible interview questions. There is notes also that is having interview questions at the back. You will get those notes, right? You will like start preparing right from the day one. right? So after that, we give you advanced course, we give you 1 week, and then we again take mock interviews, right? And again, there is a threshold. So if you get the marks of that threshold or above it, so you will get to add to the placement support. Like that. So you have to score 8 or 8 and above to be added to the placement support, right? So that is how we carry on for it. Correct. So this is the next thing that I was supposed to discuss. Now, next is, as I told you, so let's move to what is physical design to get you into the idea of what we are going to do. So to understand the VLSI and as a physical design engineer, where do we work? Let's first discuss that what is a chip design, what is the difference between chip design and chip fabrication, right? So here, so there are two things. First is chip fabrication, and second is chip design, right? So I will, the first is chip fabrication, and second is chip design. So we are going to see that what are the aspects they differ from. So see, we will be always like, we are the part of design team, right? Fabrication is happening in the foundry, fab labs we are saying. So that's a kind of factory. We call it as foundry, right? Fabrication is happening over there. So there are many. So if you have learned it in your college days, so there is a lot of chemical process that goes on. So nowadays we work on nanometer technology, right? So nanometer, we are not even able to see that fat with our naked eyes, right? So obviously the clean room, there is a lot of aspect related to IC fabrication nowadays is there, because the machineries which are there, they are working on nanometer scale, right? So you can just think, so many chemical processes are happening on that level, on that scale, correct? So that is fabrication, right? And what is being fabricated is designed by you. Now the design engineers are again divided into front end, back end, and then again they are subdivided into different streams, correct? So this is the difference. Now let me give you the idea. So what it involves. So what chip fabrication involves? So manufacturing chips, ICs in fab labs, fab labs or fabrication plants. We call them as fabs. This is what is manufacturing is. So what is chip design is? It involves designing the structure, designing the structure, converting whatever was the idea initially. Anything is the idea that I want a chip which has to be functioned like this. I want a Wi-Fi chip. Right now, that Wi-Fi is going to work near the furnace, right, in some factory. So you need to make sure that okay, it is near a furnace means temperature will be more. So you have to pay attention to all those things also. Correct. So designing the structure law. So what is the logic behind it, and converting it into layout of IC, integrated chip, right? So we are the ones who is related to design, right? Then who does it? Who does it? Right? Chip fabrication. Who's doing chip fabrication? Have you ever heard about foundries foundries like TSMC? It's Taiwan Semiconductor. Mostly, so it is, that's why VLSI people are goes to Taiwan a lot, right? TSMC is one of the biggest foundries. TSMC, UMC, Global Foundry, Foundries, then SMIC, right? So these are the foundries. These people are not into design. They are not having their companies where the engineers are sitting and designing also. It is like they are just fabricating the ICs, right? You have to give your files to them, they will fabricate. They are not into designing at all. So those are TSMC, UMC, Global Foundries, and SMIC, right? And there is a thing called as IDMs. IDMs means these are the companies who design also, who fabricate also. We have two such companies which are doing this, Intel and Samsung, right? So Intel is into design also, right? You will get job in Intel also, you'll get job in Samsung also. And these two are fabricating. They have their own fab labs also, right? So this is how the chip fabrication is happening, right? And fabless, so designing the chip. So there are a lot of fabless companies means which are not having fabrication labs, correct? So those are called as fabless, FABLE, fabless companies. What are those companies? Qualcomm, AMD, and then like NVIDIA. NVIDIA. And obviously designing is also done by Intel and Samsung, which are called as IDMs. Right. So ultimately, these are the giants for which you will be working. Right now, as you go along, you get into the industry, you get to learn about the things. You will get to know there is a concept of service industry and a service industry, and these are the product-based companies. Right. So ultimately, service industry. If you get job in service industry, you will be doing work for these companies only. But your base company will be your service company. So you will go there, you will do your work, you will do your project for 1 year, you will come back to your company, right? And you will be there in their payroll, right? So it's a different, another service company and product based company concept is there. You will get through, you will get an understanding once you are inside it, correct? So I'm not going through it right now. So so there are obviously, there are the tools which they are using. What are the tools which these chip fabrication are using? Lot of manufacturing tools like caliber. They are using Tessent. They are using EVS, right? Then, like what we are using now. Here comes front end, back end, verification team. Lot of teams are involved here. So we are using EDA tools. EDA tools like what design compiler, like I told you that we are going to use for synthesis, ICC2, right? Innovus cadence tools, ICC2 CAD. So these are synopsis tools. Innovus FC Fusion compiler. So there are the tools which I wrote earlier also. So these are the tools which we use as a physical design engineer. There are again more tools used by front end, right? So these are the tools. So tools are different for both of us, right? Fabrication team and design team. right? So these are the key tools. Then what are the processes we go through? So if chip fabrication is happening, so there are, like I told you, there are a lot of chemical related processes are there, right? You once go through the what is the IC fabrication process, right? You will get to know a lot of chemicals are involved in it, right? So some of the name I'll give you: photolithography, photolithography, itching. We must have, so as as a electronics engineer, you must have done, you must have created a PCB. Etching you must have done. For sure, you must have done etching, right? So we created track. We covered that track and we just immersed that in one chemical for overnight. In our time, it was overnight immersion. I don't know now if something else has come. So when you take that out, whatever you have to remove it so your track is prepared, right? So that is like, it's a big PCB. Now the same thing is happening, but in nanometer scale, right? Where you're not able to see the devices with your naked eyes, and there the connection is happening, right? This teaching is happening. So it's a very high end technical process. So etching, doping, we know what is doping, deposition, and so on. Many processes are there, right? Right. If you Google, you'll get to know with this. And here in CMOS also we give you the one idea about how things happen like that. So process. So here what process our design, when we are designing, how it is going to, what all process it is going to. So RTL coding first. Some idea is there that's getting converted into coding, right? That's RTL coding. Then synthesis. Then physical design. Right? I'm going to explain like walk you through the ASIC design flow. There I will be explaining you all these things, and in between verification also, right? These are the process by which one by one our design goes through, correct? Then what is the final output in both the cases? What is the final output? So silicon wafer with integrated circuit, right? What is the output? So the output from the design team, the physical design engineers are the last team. From them, the files are going, right? So we, after PNR and all the sign off processes, after the verification, we create GDS2 file. It's called as GDS2 file, right? So GDS2 layout file. GDS2 layout files sent to foundries for fabrication, right? So obviously, if I talk about, talk about dependency, both fabrication people are dependent on what design is coming from us, and we are dependent on, if we design one chip, so that has to be fabricated. So we are interdependent. So dependency, foundry, foundry manufacturers, the foundries manufacture chips based on design files, which is sent by us. Chips based on design files that is sent by us. Designers, us means us, designers rely on foundries We rely on foundries to manufacture the layout. So this is the difference between chip fabrication and chip design, right? We are the ones who are working on chip design, correct? So on this point, let's take break for 10 minutes. Right now it's 10:37. At 10:47 again, I'll start. Online students, am I audible? Am I audible?
Yeah, you are audible.
Thank you.
So, I have a one note. Generally, this is the same thing in offline people also see.
In offline, right?
Mm.
Yes, yes. So you're
Or
audible.
offline trainer will separate and online trainer is separate.
So these classes will be having, each classes are having online as well as offline students. We are going to start this meeting for online students, and offline students are also sitting with it.
Okay, that means one projector is connected and you are sharing same thing, right?
So
Hello.
now yeah, yes, yes, I said
Yeah.
yes. Uh, Now the next is, so as I told you that GDS2 is what goes from us, right? So now let's move to physical design, right? So the very first thing is, what is GDS? Or what is GDS2? So we all of us have created that CMOS structure, right? So in our CMOS, we created this CMOS structure like this. So this is VDD, this will be my, this will be my VSS, right? Some, and well, we used to draw like this, something like this, right? And well, okay. Some connection. So here, if this is VDD, this is VSS, right? Uh, Here the polysilicon is, so I will use, so here it will be polysilicon, right? Something, every one of us has done this, right? This is inputs, outputs that we draw. Again, they are connected in this way. So there is a connection with VDD here like this. And here as the connections, I'll create a connection on in black color. So this is, some connection here, something is here. Then here it is, these are connected like this. These input outputs are connected here. Some more connections, we have here like this. So basically, your GDS2 is having all the information like this. Right? So this is VSS, this is V in, this is your output, you will get V out. Something like this we have already, all of us have done in our CMOS in colleges, right? So this is what all these information is there in GDS2. So what is so obviously now you imagine, so this is one CMOS structure we have created. Ultimately, your design is having like thousands of CMOS, like FinFETs, right? So obviously those are also going to have this polysilicon input, output, VDD, VSS, and well, P substrate, everything, correct? Input, output pins, everything that also is going to have fin. It is going to have, correct? So all these information, the physical information is present in GDS2, right? That is going to the foundry, and they have the physical information. Okay, this is the connection. Now this cell is connected to this cell using this track and all those things. right? So what is GDS2? So GDS2 is GDS2. So it is called as graphic design system. Sorry, graphic data system. Data system. It is having, so all the, so this is a standard file having the physical layout of your chip, right? This is a standard format having physical layout of your chip, right? So basically it is used, so you can say the foundry will take this GDS2 and manufacture it. So it is going to have the information out what is the structure, what is the interconnection, just the information about what all cells are there. There will be thousands of the cells, right? Many cells are there, they are connected between each other, those are called as interconnect. Obviously the connection will be using metal, right? We use wire over here, big track over here, right? But there it will be a metal layer, like metal layer which is there present. They lay down the metal layer over there, right? They have to lay down the metal layer. So all the information of your cell, the physical information which I drew over here, right, of all the cells and their interconnect, these information are present in GDS2. What all information? Layout of cells and interconnect. That is the work of foundry. Will take it, fabricate it. Correct. So that is now. So this is GDS2, which I talk about, that we are the last people who's creating GDS2, and that is going to your to the foundries, right? So this is GDS2. Now let's let's talk about actual IC fabrication, how the idea gets converted into a IC chip, right? What is that flow? That flow is called as ASIC design, right? And we as a physical design engineer comes in between that flow. In between somewhere we start and we end up with creating a GDS2 file. Correct? So let's ASIC design flow. I think many of us knows it. Do you know it? Do you know what is the full form of ASIC? You know it, but you forgot. I don't believe that you don't know it. You forgot. You should say, ma'am, I forgot. Do you know something application specific? Are you able to recall it now? Online students. So it's application specific IC, integrated circuit, right? So nowadays, earlier, see, if you remember, earlier there used to be, even though one calculator, when the ICs just came into picture, right? So there was just one concept. If they are fabricating the IC, it will be a computer IC, means it is able to do multitasking, many things, programming, everything. So even though they wanted to create a calculator, they used to create the whole chip which can be function as a computer and just use it as a calculator, right? But it is like we only want, so for example, I will give you a layman example, that you only want, uh like there is a full thali present in front of you, you only want to eat sweet, but still you have, so somebody is giving you full thali, right? So it's a waste of time, it's waste of money. Correct. So we came up with the with the concept called as ASIC, right? ASIC means application specific IC, right? So nowadays, if you see, there are many electronic toys are also there. So toys are not having ICs inside them, which can work inside a computer, right? The toy is supposed to just create some sound, right? When some button is pressed, it should create some sound, different sound maybe, or some light. That's it, right? So that its work, it is going to do only that work. Your Wi-Fi router is going to just process the signal. That's it, right? Receiving, and giving out. That's it. It's not, you cannot use it inside the computer and do some kind of programming on it, right? So it's application specific. So what is happening, rather than creating the whole computer system where memories are also there, graphic card is also there, does that small toy require graphic card? No, right? So we are not adding it over there. Correct. So that is the thing. So only application specific ICs are created nowadays. So that is why, because it is saving our time, it is saving our saving the cost of it also. The costing is also saved. So that is application specific ICs. That design flow we are going to see now, because we are going to work on that. So so now the very first thing is, do you know what is now integrated circuit? We know it, right? Integrated circuit. Integrated circuit are having, so transistor, we are using CMOS, right? We are using FinFET. It's not, it's nothing but a transistor, right? So FETs, it's nothing but FET, field effect transistor. So these transistors, thousands, lakhs of it present inside on, like present on one silicon wafer is nothing but your IC, integrated circuit, right? So, and only single die is having it nowadays. ASIC is having, so if memory is required, that is also present in that single die, right? So earlier it used to be like in 90s, in early 90s, if we wanted to have a computer, full computer, so one CPU is coming, right? If you want more memory, so we had to add more memory. One full box used to be there for memory. If you want to have if you want to play games on it, we used to purchase graphic card, and it used to be really pricey at that time, right? So we used to have graphic card also, and such things if we are adding in our that computer, the CPU's box, right? So it used to be get heated a lot, so fan also used to be there present, right? That is early 90s when we used to use computers. But all those things now present in your phone, right? Except the fact, okay, phone is having, so inside one chip, are you, so if phone is there, are you purchasing memory from or laptop? Let's take the example of laptop, right? Laptop is there. Okay, yeah, memory in GBs, there are different this, that is fine, but we don't have to do take everything and then connect them and then one big system is created. It's already present, right? Graphic cards nowadays we don't purchase at all. It's there present in your system, right? Our phones are having those systems. We are playing high-end games on our phones or tabs, right? So that is a so what is happening now, that ASIC, that integrated circuit, earlier they used to be there but bigger in size. Now it's smaller, and now we are working on the evolution is SSI. So it is like we are VLSI, then SSI, small scale. ULSI is also there, right? ULSI, so VLSI, thousands of transistors, lakhs of, so ULSI, billions of transistors, few to billions of transistors, right? VLSI, thousands of transistors, right? SSI, less transistors, like that. Correct. So this is how the evolution of your IC is done till now, right? And we are working towards it, and we are constantly working on reducing the size. Means, like if my palm is an IC, is a size of the IC. So today, if I am able to hold 100 transistor inside this much of the area of my palm, right? After 2 years, I will be able to place 200 transistor in that, right? So that is how we are working constantly on reducing the size, on making the system faster, and making the power better. PPA, performance, power, and area, right? Earlier, the like click, we used to click in our bigger systems, that PCs used to click, it used to respond us after 2 seconds, right? Nowadays, it's not a case. You will, if that happens, you will say latency is too much. I'm not, it's too slow system, right? You will say it like that. So we have continuously worked on performance, making the system faster, right? Power. Earlier, the phones, the touchscreen phone, when it came, right, the power backup was just for 2 hours, 3 hours, 4 hours. fully charged, if you're continuously working on it, 4 hours, the battery is down, right? We have to make sure that we are not using it more throughout the day if we are out, right? So now, even though you are continuously playing, chatting, continuously some of the other apps are working, still it is working fine, right? Towards the end, the battery drains out after the continuous work also, right? So that is how. mm, so that is how we have worked on power and area. Systems are smaller, right? We are moving with full computers with our palms. So that is how the ASIC is worked. Now we will see the ASIC design flow. Do you know? So ASIC design flow, if you remember now, if you came to know, you don't remember the flow. Okay, fine. So right. If you recall, you can let me know. So it is like first specification. Then I'll walk you through every each and every aspect of it. Just I'm writing the flow right now. Architecture design. Then RTL design. Then RTL verification. Then synthesis synthesis. Then DFT on it. Then floor plan. Then placement. Then CTS. Then routing. Then sign off. And it can be then fabricated. Fabrication. After the fabrication, it goes for packaging and testing, right? And you will get a chip at the end, right? Now, where do we fall in between all these? So we are the ones who are working from here. So synthesis, DFT, we just add in between floor plan, placement, CTS, routing, site. This is where physical design people work, right? Till here, it is called as front end. From here, it is called as back end, right? We do STA also in between. We do STA also. What is STA? Timing should be, means some frequency is given, right? We know that our designs are working on frequencies, electronic designs. We want, if whatever is a given frequency throughout, when we are converting that logic into the layout, it should work on that frequency towards that. So we make sure of it throughout the design in each and every step. That is called as STA, right? We keep on checking timing. And if there is any issue, we keep on fixing it at each and every stage, like that. Okay, so now I will walk you through quickly to the ASIC design flow. So the very first is specification. So if you have so this is specification. See, so what happens is any chip is first an idea, right? I am a client. I want some chip to be prepared, which has to work like which has to maintain certain temperature. It has to work inside certain more bigger like technology, bigger system, you can say, right? It is a part of some bigger system working in some other area, right? So specification is your client will give you the idea that I want the chip who is going to work like this, right? I want it to work in this much frequency, this much fast it should work, right? So that is the idea it is giving us, right? So That is called as, so here performance. So now that idea gets converted into the blocks, right? Some idea you are having that when this a button is pressed, the timer should ring, right? So it's a flow chart, right? So that work is done. So specification is actually getting all those ideas, right? So in specification, we will be having some idea that, okay, so if this is a chip, so roughly people can draw different things. So like it will be working on RF, it will be working, so this much like memory will be there, right? There will be mic present, okay? There will be Bluetooth present, there will be Wi-Fi present, okay? There will be maybe obviously ALU will be there. There will be some GPU will be there, right? There will be speaker, right? So like that, there will be PLL. Obviously, to generate the signal of the clock, PLL is required. Oscillator or PLL is required. Phase lock loop, right? There should be a light sensor, right? So like this, the specification comes to us, right? Specification according to that what all things the client wants from the chip to do, right? It is having all those things. This is called as specification. Now comes the architecture design, right? Now comes the architecture design. Now what architect will do? So architect will take all these insight that, okay, these are the this, so it will convert that those ideas into a flow chart, right? So if it is a light sensor, okay, when light is this like this much light falls on the sensor, this timer should or it should display this or something like that. So here the architect will convert that idea into a flowchart, right? And so here architect will it he develops a high level design. High level design means like block level design, you can say, not in detail, but he will know that, okay, these many blocks may be possibly present here in this particular IC, right? So from specification, right? So he will represent key components in a block diagram. He will be the one which who will be taking who will be telling you what will be the area, what will be the power, what roughly will be the efficiency, right? He will be telling you the estimate area, power, and cost efficiency. This is the work of architect, right? Ideas came, ideas got converted into a flow chart or a block diagram, correct? Now it's a block diagram. So obviously it has to be converted into logic, right? Because ultimately we are having AND gate, OR gate, NOR gate. Those MOSFET are nothing but these basic cells, right? So that idea which is there, it has to get converted into logic, correct? So that is done by the front-end RTL design people, RTL people. You must have done Verilog programming, have you? Yes. So that kind of HTL programming is done over there, right? So the next is RTL design, right? RTL design, here the idea gets converted into logic. right? Some idea is there that converted into logic. So here, so for example, simple example I'll take. So if there is 4:1 marks, 4:1 marks, right? So what we are having some, so this is what ABCD. This is what S0, S1. This is what output. It is 4:1 marks. We know it, right? It's a combination, it's a combinational this. So there will be select line S0 and S1. Two lines are there, four combinations, 0001, 1011, right? What is the output? Output will be A, B, C, D, according to what is the select line right now. Correct? This is simple mux, which is present, right? How, so if you have, if you know the how the RTL code is run, so we actually write the module. So like this, module M 4:1. So I'll do one thing. So what we do, module M 4:1, like that something. So, and here A, B, C, D, and S0, S1, and out. Something like that. This will be there. Correct. And here we will have input, we will have output, outputs like that. We inputs, outputs, wire interconnection if it is there, right? We will, here it will be body of, here it will be body of your design, whatever module you are working on, right? The logic will be present here, correct? And the logic will be present here, right? And at the end we do end module. Correct. So that whatever was the idea was there, flowchart was there. Now it gets converted into RTL design by RTL people. So here the actual idea gets converted into logic. Got it? Fine. Now RTL. So next is what? So okay, this is done. This is RTL. So RTL, yeah, RTL design. RTL design. Correct. So now this is done. Architect has created the flowchart. That flowchart has now got converted into logic. Right now we have got the .v files, the RTL files. Correct. So RTL is done, but who will tell us that the RTL is functioning according to what was the actual specification of the client, right? Whether the design is working, functioning properly the way it is specified or not, that is done by RTL verification. It will verify your RTL for the functionality, whether the functionality is intact, according whether it is following the specification or not properly. Correct. So that is the work of your. So next is what? RTL verification. RTL. Next is RTL verification, right? So RTL verification will add certain test cases to your design, right? It will test for functionality. So if you know, so there are, I will just, I can tell you over here. See, let it be. I will just yeah. So this kind of, I have not opened it. Just I'm showing you this. So this kind of waveform verification they do. That the input is going at this time, whether output is properly coming at particular expected time or not, or whether it is coming 1, if it is supposed to be 1, whether it is coming, if it is supposed to be 0, whether it is coming or not. So they are actually looking after the functionality, whether the design is functioning properly or not. They will take your design, they will added whatever number of test cases they want, they will add the test cases, each test cases they will, so they are also having lot of tools, right? They will apply a lot of test cases and test your design like this, right? The waveforms they will test. This is what RTL verification team will do. Okay, so this is now the verification is done, right? They will apply test cases, they will analyze, waveforms. Correct. So now the logic is created and the logic is verified. Correct. It is verified. Now comes us. Right. From here, synthesis has, so till now have I taken the name that this technology is being used? You know what is technology node, right? As I've told, someone was asking, we are working on 28. We are having 28 nanometer technology. Correct. What is technology? If I say 14 nanometer, what does that mean? The answer lies in CMOS. Do you know it? See, we know CMOS, right? We know CMOS. We have, so I'll roughly just draw two things. So this is source, this is drain, right? We have gate also, polysilicon and all those things. I'm not talking about it, right? So we know the channel is formed here, right? Source and drain, in between source and drain, correct? The distance between the channel is nothing but your technology node. Technology node. If I'm saying that we will be working on 28 nanometer technology, or sometimes we call it as 28N, right? That means the distance between whatever MOSFET we are having in our design, right? The distance between source and drain is 28 nanometer, right? When we talk about 14, so 14 nanometer will be, the distance in source and drain will be even less, 14 nanometer, correct? So till now, did I take the name of this technology node we are working on? No. Our design is technology independent till, right? This RTL file, I can map with 28, with 14, with 5, with 7, with 1, with 3, with 1.5, any technology files which is available with me. Correct? So that is what now we will be doing. So next is what? Next is we are now doing synthesis. Right? Synthesis. Synthesis. What does synthesis do? It converts RTL code. I will precisely write. It converts technology independent RTL code into technology dependent gate level netlist. Right now you will see here, so all the cells related to technology, right? Here your netlist is, your design was there, now it is mapped with the technology dependent cells. That is what the synthesis is doing, right? I will show you. So I actually do not show you the netlist here. So you will see in gate level netlist, there will be no if statement, else statement. There will be nothing like that. You will just see this. Okay, let it be. I'll show you one. Uh, I have one diagram here. So we are going through this. So this is what, just give me one. So see, so this is what, I hope my one presentation slide was there. I hope online students are able to see the presentation slides. Hello.
Yes, ma'am.
So this is RTL design, which I was talking about, right? 4:1 marks example I had given. So this is something you will see, correct? Then comes the like RTL verification. So as I told you, lot of, so here, yeah, now it is, I guess it's better here. Now you are able to see it, right? Yeah. Okay. So something like this, not able to zoom it. Um, Okay, I'll zoom it later. So you can see here test cases are there. As I told you, verification. Okay, so test cases are there present. Your verification team will apply a lot of test cases in your design, right? And they will analyze the waveform, whether suitable output, the expected desired output is coming or not from the design, right? This is what is happening. I will just zoom. Now, are you able to see? I'm zooming, online students, I'm zooming for the sake here on the projector, it is not properly visible. So that's it. Okay. So this kind of test cases you will be able to see, right? So this I was talking about, like this waveforms. If you have done Verilog system, Verilog somewhere in the college, also in very basic level, is also fine. You will understand this, that what's happening here. Correct? Fine. So this is what now this is happening, right? So now next thing is, I need to exit from this page. Okay. Now what will happen? So you will find after the synthesis, it converts that logic. Now the logic is there, which is technology independent. It will convert that into technology dependent files. Now you will see here, you will not see any if statement, else statement. No complex things will be there because your synthesis tool has worked on it properly, right? It has replaced those if statement, all the behavioral code into some logic, right? So it has replaced it with AND gate, OR gate, NOR gate, or all those things, right? I'll give you example here. So examples. RTL is verified. Now see here. So this is how your gate level netlist will look like, right? You're able to see it, right? It's clearly visible, right, from behind. Yeah. So see, this is a top module. You see first what I am. So first you see the top level model, right? So this is the bigger rectangle is nothing but the top level model. right? You can see A, B, C, and Y. A, B, C, and Y. That's the input and output, correct? Now inputs A, B, C, output Y, net is N1. So here, inside that, two small modules are there. But outside those module only, N1 is some wire connection. So it's showing N1, that's it, right? And it's calling two modules, T1, temp1 and temp2, right? So where is temp1? This is temp1, right? This is temp1. It is having AND gate, OR gate, and inverter. Online students, I hope my presentation slide is available, is visible.
Yes, ma'am.
So yeah. So temp1, this is nothing but the temp1, which is called inside the top module. It is enclosed inside a top module, if you see here. Correct? So it is input MNO, output P. Correct? Output P. And inside some interconnects are there, N1, N2, that is defined. What all gates are there? AND or an inverter. AND or inverter. End module. Correct? Another thing is called over here temp2, right? Temp2. This module is nothing but temp2, right? Inputs are Q and R, output is S. Inputs are Q and R, output is S. Only N1 is present. That is so. And what all things are there? AND gate and inverter. AND gate and inverter. Right. So this being my top module, it's calling temp1 and temp2. Temp1 and temp2 itself are having some of the basic gates, some of the functionality, you can say. Correct. So that is what is your so that is what your netlist will look like. Here you will not be so. When I was talking about RTL, we were able to see certain case statement, if statement, else statement, right? Something is architecture design. Yeah. So here we were able to see case statement is there, right? You will not see any of it inside your netlist, right? It's all solved. We know how it is solved. K-map, you know, right? We know Boolean functions, right? Using that, it is solved, right? So in extensive synthesis process, we actually explain all these things, correct? Now I will continue with this diagram because diagrams are present here. So ASIC design flow, next is DFT. Now your netlist is created, correct? So netlist is created. It is again, so here there is one thing called as scan chains that is added. Some testing if we want to do, right? We want to do certain, hello, please mute yourself. If some testing we want to do, correct? Even after the tape out. So we need to add certain files because for that purpose, that is called as DFT, design for testability, correct? So that is happening. So earlier, the design is looking like this. Flip-flops are there. Obviously, the flip-flop will be there in our design. Some combinational logic means AND or NOR gate basics, all marks, demarks, all those things may be there, right? So combinational sequential cells will look like this. But once design for testability files are added, it will look like this something. Scan enable, scan input, all those things. So when you are studying synthesis, you'll get to know what it is. Right now, just I'm giving you the idea. So DFT is done over here. Some scan chains are added in synthesis stage, right? Fine. Now, after, so I'll stop it because now rather than showing, I will draw, right? So here till here, synthesis is done, right? DFT is done on the synthesis, right? Now comes the PNR. See, so here synthesis is one individual you can say area of backend, right? And now comes the PNR team. PNR team will do floor plan till sign off, right? So what is floor plan? Now I will start with floor plan. I'll give you the idea what all things we do. Now till now you don't have the idea that how your chip will look like, right? From here, actual everything is logical till here. In synthesis also, everything is logical, right? Simulation we are doing everything, so we don't know what is the layout. We don't know how it will look like, right? How the cells we are going to place. Now here, from here, it is going to actually take shape, right? So what do we do in floor plan? We create core and die area. What is core and die area? Which is actually the shape of your chip, right? So basically, let me tell you here one small thing. So this is your chip. Normally, we have seen rectangular or square chips, right? So the whole chip is cannot be fabricated, cannot be designed at a time, because there will be lakhs of components. So what do? They divide it into small blocks, and like this is A, B, C, D. This is a full chip, right? It is divided into different blocks. Each block is having different functionality, right? And individual physical design team are working on individual blocks, right? They are doing full PNR flow, full flow of PNR, which we have just discussed, ASIC flow, right? They will do full flow on individual block, and at the end, they will collect all the block, connect them, and create a full chip. It is a time saving thing actually. To save the time, they are doing it, right? So we are going to work on block level diagram, right? As a fresher, we work for 5 to 6 years. We work on a block level diagram, right? Block level design. So here floor plan is there. So this is how my block will look like, right? L shape is there, T shape is there, U shape is there, rectangle is there, square is there. All these shapes are possible, which I drew here also, right? So now here, rows are there, right? Core and die is created. So what is the very first thing? Core and die is created. Right? This is nothing but your core. This is nothing but your die. Right? Here, bigger. So here, after that, ports are created. Ports are placed. Ports. These are nothing but pins. Ports of pins are placed. Core die created, and these are your pins. These are your pins. Like this. All over or one side, according to your specification, you will pins are placed. After that, so there is one if your design is multi-voltage design, it is not always possible that your design is working only on one voltage. It may work on lot of different voltages, right? So if the design is multi-voltage design, we create voltage area, right? So voltage area is created here like this, somewhere in the corner, like this. Whatever is the requirement, the voltage area is created. After that, once the voltage area is created, so macros are placed. What are macros? Those are ready IPs. Ready IPs means, for example, some of the electronic devices are there which are used in each and every, all the designs, memories, right? We require memories everywhere, right? So what they have done, they have created a memory, and that block is present already functional with your company. So you just have to pick that, keep it in your design and use it. Your that much time is saved, right? Those are called as macros. Those are bigger in size, normal then bigger in size, right? So macros are placed, right? So macros will be bigger like this. They will be bigger in size like this. Macros are placed. Once the macros are placed, right, then comes physical only cell placement. These are certain cells which make the design manufacturable, right? Manufacturing, here everything is simulation based. right? Actual when your silicon is under the machine, right? Etching, different fabrication processes are happening, right? Obviously, some more like environmental factors, many factors are getting added, which are physical factor, which is not there in a simulation, right? Which is we cannot have those conditions in simulation, right? So because of those conditions, some functionality issues or errors may appear later on, right? So that's why to avoid that, we have certain cell called as physical only cell, which will not which will not let the functionality of your design affect. Right? So we will apply the physical only cell. Here, we also do power plant. Your flow. Here, now the logic starts getting converted into layout, right? That is the first step in PNR, which is called as floor plan, correct? Next is what? Now floor plan is done. Next is what? Placement. Okay, so placement is what? Now here, next is what? Placement, right? Here, what will happen? So already your floor plan ready diagram is present, right? This is your core is already present. Okay, your core is present. Now the bigger macros are there, pins are there, everything is there. Now all the standard cells means flip-flop, mux, AND gate, OR gate, NOR gate. So there can be, like I told, that Orca top is a design netlist which we are using, having 52,000 cells, right? And 40 macros. So here, how your Orca top will look like in floor plan, you will see 40 macros, you will see all the ports. There are 290 something ports or pins, you can say, right? You will see you will see a voltage area, right? Now, when you come here in placement, now you will see after the placement, you will see the standard cells also placed. So if this is your core and die, right? These are called as your site rows. Actually, the standard cells are expected to actually sit exactly on the site rows, right? So here you will see all the standard cells sitting like this after placement. So even though there are bigger blocks in between like this, for example, like this, bigger macros are there. So standard cells will be sitting around them. There may be gap present. They may be touching each other. Everything is allowed. This is nothing but placement. So in placement, what happens? Your standard cells are placed in core area, right? Here, the tool works on timing and congestion. As I told you, we want our design to work on particular frequency. We continuously work towards it, right? We tool also do it, right? It continuously work on timing and congestion. This process we called as optimization. It will make certain changes, not functionally. Optimization means the tool may make certain changes, adding buffers, inverters, upsizing, downsizing, everything. Not functionally. It will not change the functionality of your design, but it will try to attain whatever is the timing of the design. That is called as optimization. So here tool internally works in this. The runtime of placement is really like it's for us 52,000 cells, it takes 1.5 hours to 2 hours. Right? In industries, you may have bigger program, so 36 hours, 24 hours. Here we want to learn. We don't have that big, don't want to have that big runtime. Otherwise, how will you learn, right? So still we are having the runtime of approximately 2 hours for the placement, right? So because tool is continuously working from inside, doing some changes, right, to meet the timing. Here, If the timing is, you will check the time. If the timing is violated, we also add some fixes. We do some fixes here in placement stage, right? We manually, we can do the fixes. Those are called as fixes given to meet the timing requirements. So this is the placement. This is how your after the placement, whole everything is now placed actually. Now cells are placed. After that, the next is, and here power plan is also done, right? So wherever tool is, wherever the standard cells are placed, they are provided with power already. Correct. So here in floor plan, power plan is also done. Placement is also done. Now, what is the next important thing according to you? The next is CTS. Because if here CTS, clock tree synthesis, right? There are a lot of sequential cells. We want those sequential cells to work, correct? To work, they require what? Clock tree synthesis. Right here, so basically till now, so obviously what is happening till this point, the clock is like this. So for example, this is your core and die area. This is your core and die area. Okay, your, I'll not draw now. So this is your flip-flops which require clock. They are sitting away like this. Some are here, right? This is the port. This is a port where clock is coming from outside, right? Till now, your tool is considering the clock is directly reaching all the sequential cells like this. And according to that, it's giving you the time like this, right? But this is not the case actually. This direct connection never can happen, right? So after clock tree synthesis, you will get actual how the clock is built. So clock tree is actually built, and after building of the clock tree will look like this. So there are different formats. I will be just drawing one type of format. Okay, so clock tree will look like this. After here, so it will get divided like this. Here there will be another flip-flop. Here there will be one flip-flop, another flip-flop. It will go like this. Again, it will get divided like this. Different flip-flops like this. This is called as H tree, which I drew. It is creating H, right? H pattern. Okay, this is mostly used. So there are different patterns. So when we learn CTS, we learn all those patterns, how the CTS is built, how the clock tree is built. Right? So clock tree being most important part of your design, because your flip-flops are the reason your design is actually achieving the timing. Your design is able to work on particular frequency. Correct? If flip-flops are not provided with clock properly, right? Your design will not function properly. Correct? It will not work on the said frequency. So it's really important to provide all the sequential cells with proper clock. That is happening in clock tree synthesis. Here also at this point of time, the tool is working towards congestion and timing. It's doing different optimization from inside. What I told you, what is optimization? Working on doing lot of changes. Optimization means doing lot of changes to attend the timing, and the congestion should be least. The congestion should be less and timing should meet. The tool is working towards that process is called as optimization. In that process, it's doing certain changes, is called as optimization, right? Here also, after CTS, right, we check the timing. If tool will do the timing fixes to certain extent, but you will find certain violation that we fix. We give different fixes manually. So here also we do, right? Now, so what has happened till now? So what we have done, so we created the floor plan, core die is created, macros are placed, pins are placed. We placed all the standard cells also. We provided clock to the sequential cells also. Correct? Now what is next? So power is provided, clock is provided. What is remaining? Signal. Right? Signal is going from one input to another output, and like from one output to another input, and the cells are interacting in that way, correct? Okay. So now time to connect all those cells. Correct. So that is called as, that is happening in routing. That is happening in routing. So in routing, so for example, I create this 4N die. So I will, so a bigger blocks like this, macros are there. Smaller blocks like this, standard cells are also present. Like this. So like this, the connection is happening. This is your, these are your layers. These are your layers. Like this, the connection is happening. This is happening in the routing. Now, after routing, you will see all the things are connected, right? Meanwhile, after each and every step, we are also checking the timing. We are fixing the timing. After routing also, because now many connections are there. Like lot of connections are there. Power is connected. The clock is connected. Normal signal is connected. So there may be a lot of DRCs issues and all those things. We keep on fixing them. Those are really important, right? Understand that is the main purpose of physical design engineer, right? The flow is already there, right? Your placement CTS routing will happen. They have the script with them. They will give you the script, you will run it. But the issues which you are facing, you have to develop yourself to analyze those issues and fix it. That we are doing here throughout the flow, right? Analyzing and giving the fixes. Correct. Nowadays you have to, so when you are when you are like, you have to develop the analysis skill of yourself as far as physical design is concerned. Like it is a open, it is a short, okay, what should I do, what fix I will give you, right? So those method we will develop, right? So that is routing is right. After that we come to science, right? So here now I will like to open this again. I hope my full screen is shared, I guess. Yes. So, so I've explained you everything like this, right? Routing is done. After that comes the sign off, right? So as I told you that sign off means PPA. I've told you one concept called as PPA, right? Power, performance, and area. Area should be less. Performance means the chip should be faster or should work in a specified frequency, right? And power should be less. We don't want our phone is kept like this. We're not using it at all. It is getting heated and the battery drained off. We don't want it right now, right? Mostly we are having like devices which we are moving around, which we are moving with, like phones are there. Rocket science is also getting developed. They don't want the battery to drain off as soon as possible. No, we don't. We want the battery to stay. So that's why power is really important nowadays, right? That phone will not. Nobody will buy that phone if the battery backup is not good, right? So everything is now sign off means we close everything, right? We timing sign off. So we do spec extraction, timing sign off using prime time. We do in Tempest is the cadence tool, and prime time is the synopsis tool, right? So we do timing sign off that okay, the design is working on set frequency, everything is perfect, timing is not getting violated. That is called as timing sign off. Every sign off is having its own tool. So we are using prime time in synopsis, tempus in cadence, right? IR drop sign. It is used to, so IR drop, we don't want, so if proper, the voltage which has to be supplied, for example, 1 volt has to be supplied to whole design. If at any instance of time, or even for 1 nanosecond, right, at some point of time to some of the cells, 0.99 voltage is supplied, right? The functionality at that instant will hamper. It may hamper the whole functionality also, right? We don't want that, right? So that's why IR drop sign off is done. Means we make sure that at every instance of time, all the cells in each and every corner are provided with the desired voltage. That is IR drop sign. So here also, like we have Red Hawk tool to do that, right? Means Red Hawk tool is used. Here we do not do tiny like IR drop sign, but Red Hawk tool is a tool which we use, right? We have to have the information of what all tools are used. Okay. So now the final sign off is if there is any opens, if there is any shorts, if the functionality LVS, layout versus schematic, the schematic which we started with, whether the layout now which we are ended with, are they functionally equal? Right? Otherwise, it should not happen that you have started with 2:1 marks and you are ending with 4:1 marks. Is it functionally proper functionality? No. Right? So LVS, that is layout versus schematic. Right? Whatever layout we are having, is that functionality equal to the schematic which we started with? That is being checked. Right? If there is any DRCs issues, there are many things involved because the fabrication people wants us to follow certain physical rules also. This should be the spacing between the layers. This should be the width of the layer. And if that is not achieved, we are getting violations. So we need to fix all those things. Those are called as DRCs, LVS, and LEC check. So sign off after routing, the physical layout of the chip is completed. In sign off stage, all tests are done. DRC, design rule constraints. Constraints are nothing but rules. Certain rules are there given to us by the foundry. Our design should follow that. That is checked. Otherwise, your foundry will not be able to fabricate your IC, right? LVS, LEC, everything is checked to check the quality and performance of the layout before tape out. After this, the design is converted into GDS2 file. Right? So all these things, after all these things, GDS2 is, I explained what is GDS2 at the start. Now we are able to create the GDS2. Right? So fabrication, GDS2 file information is to fabricate the chip. We know what is information is there. Layout, physical layout information is there in GDS2. So now your foundry will be able to fabricate it. Right? So I've already told what are tools at the start only, right? Layout, custom synthesis. So we start with synthesis with design compiler. Placement and routing, ICC2. SPEF extraction, which is used for timing sign-off. I told you we are doing timing sign-off. Star RC we are using for that, SPEF extraction. We are doing STA. Okay, static timing analysis using prime time. To work with prime time, we require SPEF, which is extracted with star RC. So you get the exposure of star RC also, right? So ICV, so physical verification ICV is used, power sign off, prime power or red off, that is used. But we are using design compiler, ICC2, star RC, prime time in physicals. Correct? So that is. So these are the things which we do in advanced physical design, correct? That I've explained, right? It's a part from the ASIC design. Sandy checks, floor plan, power plan, pre-placement, placement, CTS routing, and site. Right? So that's all we are going to do in our physical design flow. So if you have any technical related questions, you can ask me, or else if there is other questions which you want, what is a timing, what is a fees related, this, that, manager sir is also there, Vaibhav sir is there in the meeting, you can ask him also, he will answer. So if you have any question, you can answer, you can ask me the question.
Yeah, hi. Generally, we're going to cover all the things like what you have said, design compiler, ICC2,
Yes,
and prime time, right?
yes.
These are not script oriented or only command based only.
Commanders. We are running each and every command. There is no ready-made script that we give. At the
If
end,
we
you will be having the whole script for sure because your script is created using commands. We are running the whole commands, but it's not like we are not giving ready-made script. And yes, automation also we are doing scripting in between. 4 to 5 automated script also we are programming. We are doing tickle scripting also in between that is also covered.
okay, can we implement that 32 nanometer and 40 nanometer technology with the cadence tools also?
The cadence tool, we actually are concentrated on understanding the tool, how the tool works, right?
Hmm.
So these files 28 are from Synopsys. So 28 we are not using, or for 14 we are not using in Synopsys. Cadence has provided us with 45 nanometer files. We are doing that run in Cadence. Any which ways, when the technology changes, only timing and congestion is the issue, right? And that we are learning that how to fix them, right? Means timing and congestion is more critical in lower technique. That is what is happening, right? So cadence, we are more like you have to be in a state of mind that we have to learn the cadence too, right? So we are there 45 nanometer is used. Here 28 nanometer is used.
Can we learn stage by stage analysis like how to fix congestion synthesis, floor plan, and these stages can we learn and fixing
We
congestion
are
and
doing
timing?
that. We are doing that.
Okay.
We are doing that.
Analysis. So you are focusing on more analysis, right?
Analysis flow. We are doing flow and doing analysis in between. Yes, we are doing. That is what I do, right? At each and every stage, we are doing congestion analysis and timing analysis, and we are giving fixes also. We are doing. So, we want to talk. Yes. Weber sir will be talking. Will be now joining. Please, you can ask the questions if you.
If it's possible, can you show any demo like how it's going on?
Sir, are you coming? Change it. So you can.
Yeah. Hello everyone. Myself Vaibhav. I'm the manager of the institute, handling the entire training operations as well as the placements. Okay. So I hope Ayusha madam has given you all the technical details about what are the tools we are going to use, how the training is divided into two aspects like basics and advanced, and whatever the projects. Now coming to how this training will progress and how we will be training you, we will be assessing you, and we'll be supporting you with the placements. Okay, so coming to the training part, the entire flow, as ma'am has told, that it will be going to two formats, basics and advanced. During the basics, sessions will be conducted Monday to Saturday. That will be 9:30 to 11:30 will be the theory, and 2:30 to 5:30 will be the labs. Once you complete this basics modules, the off rather than Sunday, it will be given on Friday, where Monday to Thursday it will be the lab sessions, and Saturday Sunday will be the theory session. Now, what is the difference between theory and labs? When it comes to theory, it will be conducted by the industry professionals where they will teach you. They will teach you each and every topic and they will not teach you on theoretical aspect. For example, if I want to teach you floor plan, then I will invoke the tool and I will show how what are the steps, what are the commands to be executed. You are expected. in the theory sessions to learn the concept, to have a clear understanding of how it is, why it is, and how to use it. Now, once you understood this in the theory, in the lab session, a mentor will be assigned for a batch where he will ask whatever commands the trainer has run during the theory. These are expected you to do. This is how we do hands-on practical. How you will do every session when you comes to the advanced part. You will be logging into the server tools, and you will be logging into the server, and through server you will be accessing the tools. The tools will be 24/7 accessible. Now, coming to these modules, it will start with digital design, CMOS fundamentals, TCL, then PD basics, and PD advanced. In these modules, there will be, or I can say in the entire training program, there will be three evaluations. One is post completion of your basics, another one is post completion of your advance, and the third is when you are sitting for the interview. Now, what is the reason of conducting these three evaluations? The reason of conducting these three evaluations is when it comes to the advanced placements part. See, when you start learns with the basics, a candidate when approaching to a company or when a company is hiring you or shortlisting you, they know that they are hiring a fresher. So they don't have much expectations that you should have worked on 5 nanometer or 3 nanometer. They want a fresher to be very clear with the basic understanding. I have companies who are majorly focusing into CMOS and digital. Through chip semiconductors, they came, they conducted a drive here. I asked about the question paper. It was purely based on digital and CMOS. So they have clear expectations from the freshers, from the experienced candidates as well. So once you complete the basics, we will make sure that you are thorough with the basics or not. See, if you are not thorough with the basics, when you are going for advanced, there is no use because your fundamentals are not clear. Then you will be finding difficulties in attending advanced. Once you complete advanced, we will be having an evaluation which will be throughout whatever you have learned from the day one of your enrollment till the course completion. During this time, whatever you have learned, we will evaluate. And if your score is sufficient, then we will add you into the job support group. Now, what is that job support group? Me being a placement coordinator, we receive the openings from the recruiters. If I give you the placement statistics, from last 10 days only, we have received 11 companies. Out of in that 11 companies, we are able to place around 12 candidates. Around another 8 candidates are still in the interview process. That is for all PD, DB, DFT. What you can expect as a part of placements? You can expect a package if you go into service based in the range of 3.5 to 5 because this is the standard package they have when it comes to hiring. If you go into product based, right now we have Intel requirements, we have shared. Product based has their own package like 7 LP or 8 LP for a fresher. They will take you as an intern position. This is how we will place. But when it comes to adding into job support, second evaluation test will be deciding factor. Once you complete the second evaluation, I will give you opportunities. Suppose I gave today Digicom. I have to
Yeah.
forward the profiles. Give me 2 minutes, then I will address your questions also. So when it comes to companies like Digicom, I spoke to them. They told me the requirement. They told me that in physical design, they are majorly focusing on synthesis and STA. So in that group, I will post a message that hi all Digicom is hiring specifically for synthesis and STA. It's the expectation. When we share into the group, many people apply just to check how the interview to get the experience of the interview. But in that case, what happens is if I forward that profile, the chances of rejections are more. In that case, when we give you the link, after that itself, we will do an assessment and we will tell them that since the company is focused on this, you should be prepared on synthesis and ST or power plan or power plan, whatever it is. If you prepare well and in that mock interview, if your score is good, then it will be forwarded because we see many people apply without having proper expertise on that topic. So those we scrutinize outside and relevant profiles we forward. This is how we will be providing support in the terms of placements. Now, as a part of training, we provide complete flexibility. What I mean by flexibility is there is no restriction, that you have to attend online only or you have to attend offline only. Even if you have registered for online, you are attending offline, you are registered offline or attending online, anything is fine. What is expected from what from your end or what are we expecting is to keep the institute in the loop. Tomorrow you are not coming or any other reason you are not attending. Every candidate, once you enroll for the course, a VJID will be assigned. You are expected that in that VJID, including me, the supporting staff is there or the admin staff is there. So it is expected for you to update that today I am attending online or for another 10 days I am attending online, so that we are aware of what is the progress. Now, even why we are giving the flexibility, it is because once we do the training, now also the session is getting recorded. Every session that we'll be doing, specifically theory session, because theory is where we teach. And in the labs, we are expected you to do. So every session that we'll be doing is getting recorded. We have our own portal that is called InSkill portal, through which you will be able to access all the live session recordings that will be available for 2 weeks. So suppose you have attended today, and even though you are attending online or offline, in online there is a possibility that you get disconnected or some or other reason because of which you disconnect. Even if you get disconnect for 5-10 minutes, topic goes ahead, and you might find difficulty to understand. On the same note, even if you are attending offline, it is not possible that you learn 100%. So for that purpose only, we are giving you the live session record. But live session recording should be a secondary source of learning where you revise the thing. It should not be that I am not attending session anyway, recordings is available, I will go through the recordings. Then better I have complete entire course in the format of recording my previous batch. You can enroll for that. Live sessions are interactive sessions. Now, there was an immediate requirement came from one of the company. They wanted to schedule tomorrow itself. And that if such immediate requirement comes, I don't have time to go and evaluate. So what I will ask is now also if I ask Ayushi ma'am, who are active in this session, online students, offline students, she will come up with the names. The same policy is applicable during the trainings also. So even if there are 100 people in the job support, still we will ask the trainer, there is an immediate requirement, can you suggest us good candidate names? They will suggest us and then how they will suggest us? They will see what is your involvement during the session, online also as well as offline. I will just show you a demonstration of our InSkill portal. See, this is our InSkill portal. You will be provided with the student login credentials. Can I? Yeah. See, you have a complete access where we make sure that 90% of the things are automated. It is because to reduce the time between communication time. So here, once you enroll for the course, the physical design will be open for you. Now, since we here all the videos are available, but for you it will be in a sequential, date wise. Today's session, tomorrow session, day after tomorrow session. It will be in a sequence where you can go and you can directly have what topics discussed and you can watch the video. This time is 2 hours because it is the sessions that we have, live session that we have done. Now, along with that, we have all the presentations, topic wise presentations we have done. So you don't have to waste your time. Like now, suppose I am teaching or the trainer is teaching. You don't have to waste your time in noting down the things. Okay, because everything will be available for you. This PPT presentations is available over here where you can go through it after the session is done. Corresponding to the notes as well as the assignments are available. Now, what is the see everything that we are giving to you, it has its own value. Now, what I mean by that, for example, I am doing a session, suppose I am the trainer. Even though I have suppose 15 years experience, can I give you all the interview questions asked? When I can give you topic wise that in this topic, these questions were recently asked. In this topic, these questions recently asked. But when it comes to having the interview questions, what we have done is, since we are established in 2012, it's in almost 14 years we are running this. We have consolidated all the interview questions asked by our hiring partners in the format of assignments. So suppose student comes and says that I am well prepared, provide me placement support. Still, since that person is unknown to me, I cannot believe whether he is prepared or not. But one person comes and says me, I have completed all the assignments. I am 100% sure that he is prepared well. Why? Because this PD assignments are nothing but interview questions, and all the lab sessions that we'll be doing, it will be inclined towards the assignment. So in the lab session, mentor will be focused on three things. One is to make sure that you are doing the hands-on. Second is you are doing the assignments. And the third is on top of assignments, if any other additional questions or any additional projects that he want to add, questions he want to add, he will add that also. To make sure that when you are sitting for the placements, you are industry ready. Now, the last point that I want to discuss is when it comes to hiring part, any company, product based, service based, or even some startup companies also. There are 3 to 4 rounds of interview. It starts with written test, then HR round, then the third is technical discussion, and the fourth goes for the salary discussion. Written test is majorly focused on the basics, where there is no involvement of technical team. Second is the HR round, and the third is technical round. Now, why these 4 rounds has been decided? They divide in such a way that the first round of technical written test is to make sure they are thorough with the basics or not. See, suppose I am the person and I am a technical lead and I want to take the interview. Okay, I cannot go and with the interviewer and I can ask him basic questions, because when I am a technical lead or a TL in a company, I have to handle the projects and all. So I have a time limitation. So we keep a written test where we'll make sure the students who are qualifying that written test are thorough with the basics. That's the reason written tests are 90% focused on basics part. So once you clear the basics, then if I tell you a generalized statement, whenever you go into a company, what is the company expectations? The company expectations is 2 to 3 expectations that they have. First one is you should be utilizing your skills for the project assigned to you. Second is you should follow the company protocols. Third is you should be a communicative, you should be a good team member. For those things, what is expected? A confident communication skills. So those things are taken care by the HR. That's why HR will, many times when you sit for any interview, HR will ask someone, introduce yourself, let me know what are you doing, what is your year of pass out, what project you have done, right? This is not because they want to know more about you. It is because they know how confident you are in communication. We have came across the profiles where they are very good in technical. Their evaluations were very good. But when they sit for the interview in the HR round itself, they have got rejected. See, getting rejected is not bad, but getting rejected by only because of the HR interview, only because of communication, is somewhere should not be acceptable. Why? If you get rejected in the technical interview, you will come to know what are the areas you need to improve. What are the things in technical you have to revise again. But in communication, there is nothing. They have a small, simple expectations that you should be confident. So for that reason, but we have seen many people who are coming over here, basically from Andhra or even from Karnataka, they lag with the communications. Even though they have very good confidence, very good skill sets in the technical, they have performed well in the evaluation also, but the HR rejects them. So for that reason, even though my tenure of this training is divided into 6 to 8 months, during this last 2 months, we will be doing soft skill training where group discussion, mock interview, aptitude, reasoning, everything will be done. You are expected to be a regular attending those sessions, because when I will be adding you into the job support, I will check with your technical assessment score followed by your performance in the soft skill. We will not spend 6 months or another 4 5 months. We will be specific with 2 months. Every batch will be doing 2 months before they complete the entire training, so that it will be a fresh soft skill training, which will include resume preparation also, and then your preparation will start. Interview opportunities providing you will be started by the institute. Yeah. Till here, any questions? Yes. Yes, online students, you can put in the chat box as well. Okay. So since all of you have registered or you might have got a link, we already have your numbers. Okay. Post this to your registered email ID as well as to your mobile number. We will share this session recordings to you and you can go through it. If you have enrolled for the course, the batch is starting from Wednesday. It will be starting with GWIM and GWIM and then followed by digital design. If you have not enrolled for the course, you have time till Wednesday. From on Wednesday, the first session of GWeb will start. Those who have already enrolled, they are expected you to carry the laptop on Wednesday. We will do some installation of the GWeb note editor and all, so that you can do the hands-on. Yeah. Coming to the schedule of Hyderabad, the demonstration for Hyderabad, it was conducted online today. There are some students who wanted a demonstration specifically for this coming Saturday. So we will be starting from the next Saturday for Hyderabad location. The Hyderabad branch will have their own curriculum independent, as well as the Bangalore branch will have the curriculum independent.
In this course, total how many projects we are doing? We are doing two or like three projects.
We will be doing two projects. One is on block level as well as another is on chip level.
Okay, with the tools.
Yes, we will be using Synopsys tools, and since we have the Cadence tools also, after completion of the projects on Synopsys tools, we will be doing a dedicated 1 month additional training, which will be more or completely focused on using Cadence tool, PD flow using Cadence.
That means we are not working on Cadence tools, right? Just seeing purpose only, like we are working on it also.
No. It's not about seeing. Basically, now when we do the additional 1 month, during that you will be having the Cadence tool access also. We will be providing you the Cadence tool, and theory and lab both sessions will be conducted during that 1 month.
Okay.
Yeah. Coming to regarding MacBook, yes, MacBook is also compatible. There won't be any issues for switching from day ops to VLSI, because there are many. See, right now in my previous batch, there are 2 to 3 candidates who were working in TCS from 7 years, and they were working as a system engineer. Now, recently they had completed the advanced training, and we are supporting with the placement charge. There won't be any issue. Okay, so we will share this session recording max to max by today evening or by tomorrow morning, and you can go through it by any chance if you want to revise. And if you have any queries, you can reach out to me one to one, or my colleague will also send to your email ID. Also, we will send as well as to your WhatsApp number. Any queries you have with respect to your year of pass out percentage or enrollment process, fee structure, and all, our team will get back to you. From Wednesday onwards, we will start. So, since there are no questions from online, we will end the session over here, and the team will be in touch with you for the further process.
That means Monday and Tuesday there is no classes, right?
Monday and Tuesday there are no classes because there are students who wanted to enroll after attending the demo. So we are giving them the time for Monday and Tuesday. From Wednesday we will start.
Okay, everyday sessions are going on.
Sorry?
After that, everyday sessions will go, right?
Yes, it will be everyday session. Yeah. Sure. Thank you all. Thank you for attending the session.